I think we can get started. It's 2:10. Chintan.
Yeah, sure. So we'll start with the event then. Yeah. So hi everyone. So we are Kotlin Mumbai. So basically we are a Kotlin-based community that main like we are a group of people who believe in like Kotlin for development in mobile and web products and projects. So we like to increase the community and make everyone aware about the Kotlin and make them Kotlin use in their day-to-day projects and all. So myself, Chintan Parmar, I'm an Android developer. I currently work with a company where we make applications for the HDFC and other fintech related startups. And I also love to do Kotlin and I also do open source project. So yeah, that's all about myself. And in our team, we have Rishit and Saddesh. So
Chintan,
Saddesh,
has the slides changed? I think we are not able to see the slide change. Have you changed the slides? Okay.
yes, it was in another tab. So yeah, sorry for that.
Now that's fine. So, like Chintan said, everybody, we are an open community for developers. We love Kotlin, and our conversations are focused strongly on Kotlin and Android. Chintan, next slide. Cool. So we also launched our website, which is kotlinmumbai.tech. And if you can see the website, if you go to it right now, you can visit some of our past events that we have done. You can read in detail about some of the articles that our members are writing. You can communicate with our speakers as well, connect with them. So do go to our website, which is kotlinmumbai.tech. And like Chintan said, he is an Android developer. We all are Android developers. Rishit is fairly new. He's still a student and he's doing uh, tremendously well with machine learning on Android. So Rishit is also one of our organizers. Chintan, you all have heard from him. Myself, I'm Siddesh Patil. I work at Paytm Insider, from where I work on Paytm's consumer and business applications for Android and iOS. And those are a few things about me. If you would want to check us out separately, you can visit our websites that are here. Uh, so you can connect with us as well. Chintan, how about you talk about our Discord
Yeah.
group?
So recently we started a Kotlin Mumbai Discord group. So basically, who are willing to learn Kotlin or they are into process or they are facing some issues or difficulty in building something related to Kotlin, so they can join Kotlin Discord channel and they can post their stuff there. So this is a link. We'll also post a link in the chat so you can visit it and you can join our group.
We can start with the speaker slide, Chintan.
Okay. So today we are going to talk about like as we are all Android developer and we make a project. So how to build our code base and make it better by using Google's Lint tool. So today the speaker is Subhrajyoti Sen. So he works as an Android developer at smallcase. Is very passionate about creating a good mobile experience and sharing his learning with other people as well. He also writes blogs and he's an open source enthusiast and he's an active contributor. So this is all about Subhrajyoti, and the lint is like the topic of today's talk, which is lint. So lint, what exactly it is? So it is an like powerful analysis tool that can be used to find common bugs across our code base. So Google provides a list of like default lint checks, but we can also modify and customize the rules as per our projects. So Suprajyoti is going to discuss about the same as he has already implemented this on Tickertape app to enforce his design guidelines and all. So yeah, Suprajyoti is going to talk about the building a better code base with Lint. So yeah, I would like to hand over to Suprajyoti. You can start. with the talk.
Thanks, Chintan, for the nice introduction. Let me just start sharing my tab. Yeah, I'm assuming that my slide is visible.
Yes, your sites are visible. Yeah.
Okay, yeah. Let me just put that into full screen. Oh. Uh, Hi, everyone. Thanks for joining the meetup on a Saturday afternoon. As Chintan mentioned, my name is Subhrajyoti, and I am a mobile developer on the Tickertape team at smallcase. So today I'll be talking to you about Android's linting tool. What exactly is it? How you come across it in your day-to-day usages? Why you should actually care about lint and listen to this talk. Like how you can start writing your custom lint rules based on use cases, test them, as well as start integrating them in your project. So I'll be covering all of these. Okay. Before we start with that entire talk, let's first discuss what exactly is Lint, since the entire talk is going to be about Lint. It is a static analysis tool. So a static analysis tool is a tool that runs checks on your code base without actually running your code. So it's not a compiler per se. So a compiler would compile it and get you compiling issues, but static analysis looks for other issues that are more structural. It could be certain best practices. It could even be formatting that you have decided you will keep two-space formatting, but you're keeping a four-space formatting in a particular code, or if you're contributing that code. So there is a series of things it can do, which we will be discussing. Then it is completely open source. So Android's Lint is developed as a part of AOSP, Android open source project, and hence all the rules that you see by default in Android Studio, all of it, everything is open source. It works on your Java, Kotlin, Gradle, as well as ProGuard files, XML. It can even use Lint to run on binary files, ASM classes, a lot of them. And it can be used outside Android as well. So this talk will have a few references to Android, but I'm not really assuming any Android knowledge for this talk. So if I refer any Android term, I'll be explaining that as well. And Lint initially started out for Android. I mean, Android Lint, for example, because we have Lint for other projects like for JavaScript, we might have ESLint. So there is Lint for a lot of different languages, but right now I'm talking about Android Lint. And it started out for Android, but then when Kotlin became such a big thing, and Google announced first-party support for it as a first-class language, that's when they noticed that a lot of these rules can be used for Kotlin projects as well, and that's when it started becoming such an API that any Kotlin project could start including, and it is very extensible. So the very nature of that API is such that you can write your own linting rules and then plug it into the same system, so that when lint runs, it will run the default lint rules that are there as well as your lint rules as well. It's a very extensible system, and you can run lint from both within your Android Studio as well as the CLI. So if you're some person who doesn't like making builds through Android Studio, you can have your own set of reasons we all usually have. You can run it from your CLI as well. And this also gives you the benefit that you can put it as a part of your CI, and every time someone contributes code, the CI runs, and if any lint fails, it's caught really early on, and there is no manual process involved there. Okay. Now that we have an idea of what does actually, or what exactly is it as a tool, let's take a look at how you come across it on a day-to-day basis. And these will mostly be specifically Android examples that I'll be explaining through them. And these examples are not randomly chosen examples. They are classified based on a certain metric, which we'll be discussing later on in the talk. So
The first category, first example we'll look at is internationalization. So it is when you create an app that will have different languages and hence internationalization. Now, if you look at the screenshot, you will see a TextView component is being used. TextView is a widget that you use to display text in case of Android devices. You will see that we are using a hard-coded string called test string here. And the Lint tooltip tells us that we are using a hard-coded string. We should try using a string resource. The next one is related to security. So WebView is another component that lets you open up a web page inside your Android application. And as most modern websites require JavaScript to be enabled to be able to function at all, we have to enable JavaScript in the web views as well. But as soon as you do this, Lint will tell us that setting JavaScript can introduce a lot of vulnerabilities in your app, and hence you should be really careful enabling it. Now, this would be a security link check. Remember this particular lint rule because we'll be looking at a bug in AOSP later on regarding the same thing. Next comes the performance. Here, WaveView can be assumed as a custom view. This draws wave on your mobile screen. Now, we have this onDraw method where the actual drawing of the waves happen, and it is called very fast periodically, depending upon your screen's refresh rate. Now, if we allocate an object such as paint inside this particular method, you will see that we get a warning saying avoid object allocation during the draw and layout operations, pre-allocate and reuse. Now here we can see it's a performance link, and the way you would normally do it is you'd initialize the paint object outside your onDraw method and then modify it if needed inside your onDraw method. And the last example I would show is accessibility. Accessibility is something which a lot of us ignore while developing our apps, but ideally we shouldn't be. We should take care of everyone's experiences, and hence we should focus on accessibility as well. And one such example is when you override the on-touch event, you should also override the perform click event for any custom views, and that is what Lint is telling you. Now that you've seen what exactly Lint can do and how it looks like, why would you want to consider Lint? Or why you should be considering Lint, right? The entire point of the talk. So you can have an opinionated code base. As developers, as we keep building our projects, we tend to form opinions on how things should be done. And that necessarily isn't a wrong thing. It can act as a guiding factor. Now, sometimes as a team, you might have certain collective opinions, and you would expect those to become guidelines for your particular project so that if anyone is contributing to that code base, they also follow the same guidelines or in the same opinionated manner that you have set for that particular project. Now, if these opinions can be structured in the form of rules, you can make them as certain lint rules so that if someone new is writing to the project, they don't need to remember all of the guidelines. Even if we set a few, Lint will make sure that they know about it. It will just point those out to them. And this first point also simplifies the code reviews. The code reviews become much simple. That's because once you eliminate these simple things like your formatting issues, common mistakes from your pull requests, you don't really have to keep checking for these things every time you review a pull request. The most common things are eliminated, so it saves you it's a good amount of time, as well as it gives you a positive perspective towards code reviews, and you don't always go in thinking, okay, I'll have to check for the regular issues again or formatting issues again. You just focus on what matters in the pull request. And you can adhere to a style guide. So a lot of projects, not projects, I would say a lot of products have these very specific branding. And usually whatever you write or whatever UI components you write, it has to follow that same branding. And to make sure, everyone is aware of the branding guidelines, designers create this thing called the style guide. And it It acts as a reference whenever you're implementing certain components for your project. Now, if a certain of these can be created into lint rules, it's very easy for people to not miss out. So if someone is very new to your code base, they might not know about all the components that you have, the custom components. Or even if you're an experienced person in the team and you are stuck on a very, I would say, nasty performance bug, what do you do in that case? I mean, you will be very focused on how the linting, sorry, you'll be very focused on that particular performance issue. And you might forget to make sure that you are following all the custom components. You might just fix your performance issue and commit the code. But in that case, if you have linting rules, that commit will fail on the CI, and like you will again be reminded that you use this component, but you're supposed to be using this other component. Now, now I hopefully have gotten you interested on why you should be considering Lint. So let's start with the setup process. If you want to write custom Lint checks for your project, you would have to create a new module. You can call it anything. In my case, it is called Lint. And just to clarify, you do not need a multi-module project to be able to start doing linting. In my case, I just had one app component, one app module, and I had to just add another lint module. It's not a necessity that your entire project has to be modularized. Now, once you have done that, you have to go to the build drill, the dependencies block of your lint module, and add these three dependencies. The Kotlin necessarily because you might be using a lot of Kotlin features there, and the Lint API injects. So Lint has this a lot of different kinds of classes provided to you that makes writing this custom Lint rules very simple. APIs will give you a lot of passing APIs, and checks will give you a lot of handy methods to check for different kinds of things. Now, Gradle needs to know, right, that you have written these custom rules, and these are the rules that it needs to run whenever you run Lint. For that, you have to make use of a custom issue registry. Uh, I've said the name is pretty self-explanatory here. It's a registry of all the issues that you have in your Lint module, and this makes a list out of it. So whenever you extend issue registry, there are two values you need to override. First is the API, which is an integer. You don't really need to mess around with this. You can just assign the current API from the Lint library. And the second one you can see is a list of this issue type, and it is not null. So since we haven't written any Lint checks yet, we are returning an empty list. Next, you have to go to your app module or the module you want to run the lint checks in, and then you'll have to add this block in your dependencies, lint checks, project, and the module name. You will notice that this is different from how we normally add other modules. So usually you would be using something like API or implementation, but the lint tooling is very extensively developed, and hence you can see that they have a separate such function just for lint. Now, before we look at how a lint rule usually looks, we need to know about three main things. One is the scope, severity, and category. So I'll be discussing each of these individually. So let's start with the scope first. A scope tells Lint the kind of files you want a particular rule to apply to. So you have things like Java file scope, Gradle, manifest, proguard, resource files. So it makes it gives Lint a better direction that do not run the Lint check on all the code that you have in that project, or rather narrow down the scope so that less time is spent on them. And you will notice that I haven't mentioned something separately called Kotlin file scope because Java file scope also runs on Kotlin. And this is because the lint rules are written on something called UAST. You can consider it a super type of Java and Kotlin. So when you write rules for the structure, it applies to both Kotlin and Java files. UAST stands for Universal Abstract Syntax Tree. And the reason for such a thing is that when the linting tooling has been available for a long time now, much before Kotlin got such good support in Android, and hence it was called Java file scope and not really something else. And that same naming continued to make sure things are consistent. Then you have the severity. It just tells you how severe your particular lint rule is, like the failure of that particular lint rule is, and it'll discuss. And there are like four main types, and it also tells Gradle on how to behave if that lint rule fails. The first one you have is informational. As the name suggests, it'll just be more of an informative thing that you're using this class or you're using it this way, but there's other way you should know about. It's just a gentle reminder, nothing fails. Pretty simple thing. Warning is when it is something important, but not enough to break a build. So you tell the developer that you might not want to use this because of this issue. So there's other class that we have. This again won't break a build. But if you have something like error, it will break your lint task. So depending on how serious the matter is, it will break the link task. Now, fatal and error might seem very similar. Fatal is also something that has very high uh, priority or urgency. The difference is that in case of error, only your linting task will fail. But you have something fatal, even if you don't run lint, and like for example, you're trying to create a release APK for your Android app. And if a fatal lint rule fails, it will break your build. So you have to be very careful about the kind of things that you include in a fatal rule, or whatever you give the fatal severity as, but try to restrict it to things that you just do not want to happen in prod. Like you might have these certain classes where certain values cannot go to prod. It will just break the build if you have such a scenario. And the third would be categories. So it's just like the category in which your link should fall into. I mean, your link rule should fall into. Now, if you remember the examples I had given earlier, you had security, performance, internationalization, and accessibility. These are the four examples I had given, but there is a much bigger list. A fun fact here, okay, not exactly a fun fact, but something I learned recently is internationalization is called I-18N because there are 18 letters between I and N. Same thing for accessibility and internationalization, which is called L10N. So I learned of it just a few weeks ago. Yeah. Now that we know like what are the things that go into a lint rule, I'll take two separate use cases. One is for XML files, and one is for Java Kotlin files, and show how exactly we wrote lint rules for that. And this is in line of what I had spoken about adhering to style guides. So I'm taking two style guide examples here, XML and Java, and then I'll be showing the differences that come in when you're parsing these different kinds of files and what are the methods you need to override. Okay, let's take a look at the structure of a custom rule. If you remember, we had something called issue registry, which internally had a list of issues. So this is what we'll be creating here, instances of the issue class. Now here I'm creating an instance of issue, and I'll be talking about each of the parameters here. So the first parameter, the missing style attribute, is the ID of that particular link. It is a unique identifier. And whenever you want to do anything with this lint, for example, you want to suppress this lint when you run your lint gradle task. This is the ID that you will be using. Anywhere else, if certain reports need to reference this lint rule, it will use the ID. Then you have a short description of the lint rule, which is usually a one-liner at max. So this is the text that will show up whenever you get a lint or warning or error on your IDE. And if you click on no more, then you will get the second definition that we have here. In this case, we should use style to style a text view. in order to provide consistent design. Now, depending upon the issue that Lint came across, you can give a much bigger description as well. So you can include hyperlinks to certain documentation. Some people might even like give textual flowcharts. So there's a lot of things that you can mention here. And another good thing is you can use, I would say, a subset of Markdown. So you can style your text also a bit. You can have bold, italics, and a few such nice things to make sure that if you have a lot of text, it's at least easiest to digest. The fourth parameter would be the category, which we had discussed. But this kind of a rule does not fall in like your security, internationalization, performance, any of those. So we are just using the correctness as the Lint category. So we're just saying that not giving a style is just incorrect. So we will mark it as correctness category. The next parameter is a priority. And I haven't been able to figure out what exactly priority does in this case. I have tried modifying it and I wasn't able to see a difference. My guess is if you have a lot of lint roles in your projects, it will just decide on which to run first. I wasn't able to see much of it in the documentation as well. So if anyone knows about it, I'd be glad to hear. The next one is a severity, which we had discussed. I'll just mark this as an error because I want my builds to fail. I don't really want uh, someone to push a text which isn't styled and then a designer's seeing this again, the to and fro happening. So let's just break the build in case someone forgets to add a style. Because I mean, it will take maybe like half a minute to just add a style. So it's not something that would be too time consuming for the developer. And the last parameter that we have here is implementation. Now, we just here have created an issue that is more of documentation about the lint code, but where exactly is the implementation logic? In our case, the implementation logic in this file called missing style attribute detector. So we give a reference to this to our issue, and also we give a scope, like scopes we had discussed. But since this is an XML file, we will give it a resource file scope. Now here, one question might arise is, why are we giving such a broad scope to this issue? Like resource files could be layouts, drawables, colors, animations, a lot of such files, right? And text views will most likely just be in layout files. So why give such a big scope? So what actually the case is in the linting APIs is they give you certain broad scopes, and later in your implementation logic, you have to narrow it down. Otherwise, they would have to give you a huge list of scopes depending on very granular use cases. They didn't want to do that. So they kept broader scopes, and it's up to you to give more restrictions in the implementation logic. We will be seeing examples later. So let's start writing a custom rule. We will be calling it missing style attribute detector. And since we are passing through resource XMLs, we would be extending resource XML detector. Similarly, you have a lot of other detectors as well. You can have it for Gradle. You can even have it for source code. You can have a UAST detector. So there are different classes that you can extend depending on what exactly you're passing at that time. Now, once you have extended that, here you have to mention what classes will it apply to. Now we have to add the styling lint only to the text views and not other views. So here we mention a list of the classes that we want to send back. Now here you can see that we have hard coded the word text view. That usually is a bad practice, and rather you should be using SDK constants to refer to whatever views you want to. And this SDK constants file is a huge file which has constants for almost all the widgets provided by Android. So it's better to use the constant here. And the reason I'm saying that is I had an issue where I misspelled one word in a certain class. So I was initially hard coding those class names and I made one character typo and my lint rule did not work. I spent a lot of time debugging my rule and seeing if the logic for that was working fine or not. I checked if the issue registry was syncing properly. I did a lot of checks. And I think after 1.5 hours, I came back to see that there was a spelling mistake there. So please use the SDK constants. And if you see that I have used just the word TextView, now this depends on which namespace your particular class is in. So if you have written Android, you will see in XML, you just type TextView. You do not use a full qualified class name there like view.widget.txt. But if you're using a custom class, then you would be using the entire package name as well as the class name. So if your custom rule is on a custom class, then you have to mention the fully qualified name here, not just the class name. Then, like I mentioned, that the scope was very wide for our case. Here, we will override the applies to method and mention that this particular rule should be triggered only if the folder type is resource folder type and it's a layout. So now you see that we have restricted it from the entire resource folder to just the layout folder. And next comes the main part. What if, what should happen once you actually get those reference to those text views in different layouts? How should we be checking for things? So we override the visit element method here, and it gives you two uh, uh, two variables. You have the context, and then you have the element. Here, element. So here, context gives you more of context, as in where the file was, where the particular view was found, which file, location, things like that. An element is the instance of the recycler view. I mean, of the text view there, not recycler view. Sorry. So you check if now the element has attribute. Again, we use SDK constants and we check if there is a style attribute in that particular text view. Here we are checking that if element does not have the attribute style, then it will trigger the block. And you use context to start reporting the issues into the system that we have found this issue. This is the issue description, and this is the place it is occurring at. So here you can see the first parameter is the issue instance which you had created earlier. Then you have the element to tell, okay, this is the particular element it is occurring on. In our case, the text view. You have the context or get location to get to the exact location where the issue happened. So Lint can tell you that go to this file, go to row number 35, column number 3, and then you will find where your issue is. It makes very easy to figure out where the issues are from the reports that come through Lint. And then you have like a short description of what should be shown whenever this check fails. You can keep this the same as a description that you had given earlier. Now, since you have finished writing your custom lint rule, you have to connect it to your Gradle file in a certain way. Or tell Gradle that this is one of the rules that I have. So you go back to your registry class, and there you give an instance of that issue to the list that you're returning for the issues. So here you can see that we have list of missing style attribute.issue. And now this connects our lint custom rule to the linting system. This is where everything gets put together. Now, remember where I asked you to apply, get applicable elements, and I asked you to specify that please do it particularly for TextView and not ignore this. Otherwise, it would start checking all the widgets that are part of all the layouts. So we will see a use case where this is very important. There's a small bug. It's very small because not most people will come across it, but it's still a bug in AOSP. So take a look at this class. It is a random class called test class, and it has this method called set JavaScript enable, which takes a Boolean parameter. Now, if any part of my code base, I make an instance of this class, and then I call set JavaScript enabled, you can see it is actually highlighted by Lint. And Lint thinks that I'm actually enabling JavaScript for a web view here, and that I can have security issues. But if you look at this code, you will find that there is no security issue here. So the bug that ended up happening is the lint rule does not specify which class this particular lint rule should apply to. It just checks for the method name. Here, the method name is set JavaScript enabled. If there was a specification that this should apply only to WebView settings class, this issue would not occur. So if anyone wants to try it out, you can contribute a fix to this linting rule to AOSP, and hopefully by next talk I can remove the slide as well. Now coming back to the next use case that I was going to discuss, and this is for a snack bar. So if you see the white component that says added Reliance to watch list. Now, again, according to our branding, we don't follow the default snack bar given by the material components. So we had to write this custom snack bar ourselves. Now, if someone's new to the team, they might have been just very used to showing the material snack bar, and they'll keep forgetting to do that. And we would have to carefully go through every XML file and make sure that they're using, not XML, sorry, the Java files, that they're using the correct components and not using the material snack bar. So we decided that it makes sense to write a lint rule so that no one has to check for that on the pull request. So let's look at the custom rule structure for this. It is very similar to how we created the previous one. There are hardly any changes. I have not written the explanation and description part. I just kept placeholders for now because everything is exactly the same as the previous rule. It's only in the implementation that it varies. You will see that I'm using a different class called material snackbar usage detector. And then I have this file scope for the Java file scope. Now, just to remind, this will also work on Kotlin files as well. So we have this material snackbar usage detector. We are calling the detector API. Now you're using the source code camera. This will give us access to all the source code that we have. And in our case specifically, it will apply on Java and Kotlin files. Here we call the get applicable method names. We call list of make. Here it's hard coded because the SDK doesn't really give us linting rule for these very specific methods or different classes. So here we just hard coded it, but ideally you'll be moving into a constant in the same class. But the same mistake can still happen, so you have to be careful. Yeah. Now, we have this, now in case since we're using source to scanner here, we'll get a different override method. Here we're getting visit method call, which gives us a Java context, the node in that the expression, and the method that matched it. So node is part of, when I mentioned that you have this abstract syntax tree, now each part of your code base would be a part of that abstract syntax tree. So it'll become a node in that entire tree. So here I check if once I get the context, I use the evaluator API to check, if this particular method is part of this class. So I check the method which I had mentioned as make earlier is a method of this particular package and the snackbar class. Now, this is what I was talking about, where you'll have to give the fully qualified name here and not just the name, because this is not one of the default inbuilt views that we get. It is a part of material components, and hence I had to give the full path here. And here I just have to report the usage that, this, the linting issue happened here. This is the description, this is the issue. This is exactly same as how we had it for a previous rule. So I just skipped that part in the slide. Now, once you have written your lint rules, you also want to make sure to write tests to verify, they are working as expected and they're not breaking in the future as well. So you can run these as JUnit tests. Thank God, you won't have to wait for too long. Lint gives you a separate library called Lint tests, which makes it very easy to write tests. It gives you certain handy functions as well as DSLs to write tests. And the best part is, even when you're writing those tests, even there you have ID, syntax highlighting as well as code highlighting. So I'll give you an example to demonstrate that. So if you look at this test, don't bother about the structure of the test. We will be discussing it, but just look at the highlighted part. Here I have written a text view inside a Kotlin class, and ID Android Studio, or if you're using some other JetBrains IDE, is still giving you that syntax highlighting as well as code check in the Kotlin file itself. So you can see that my text is highlighted, and I'm also getting a certain error there. And that is because I forgot closing double quotes after match parent for my layout height. So if you're writing a very big custom lint rule test, this makes it very easy to make sure that you're not causing anything to fail due to some other error. If it fails, it should be due to your lint. Okay. If you start writing the test, you have to include this lint test package in your dependencies with a test implementation, because it will just be used for a unit test. So we will look at how a successful test case would look, and then we would see how a failed test case would look written. So you started as a normal unit test, you annotate with add test, and then you call this method uh, called lint, and this is where the DSL starts happening. Then you say that I want to run this lint on files. Inside files, you pass in the XML scope. So it tells you that this is an XML file that I'm trying to run my lint on. You can mention which path should Lint assume your text was written. So inside layout, I'll just mock this certain file called layout.xml, and it'll just put this text there. And this is the text your lint rule will run on, even though you're not storing it in an actual physical file called layout.xml in your code base. This is just for the sake of the test. Then you can call run. And now, since this text view has a style attribute there, nothing should fail. So we are saying expect clean, that this will run without any issues and give a successful result, and this will pass. Let's take a look at an error case. We have this similarly written. We have lint files XML. It is inside layout, and then we have this text view. Now, if you see, I have adjusted the indentation of the text view here. That is because whenever you're writing your lint tests, indentation is a very important thing, because your lint rule will tell you where exactly in the file. So it'll give you a column number and a row number where the issue occurred. Now, if you run a test case and your test runs successfully, if you change your indentation of the text view, the test will fail, because the expected output and the actual output won't match. But for this, we expect it to fail because we haven't given a style attribute. So here you mentioned that you expect an error count of 1. Now, if you had multiple errors, you could expect error count of 2, 3, whatever number. Similarly, if you expected a warning, you could mention that expect warning count 1. You can even mix them up. So you can expect 1 error and 1 warning count. Now, you have written that you expect an error count and that will pass. But you would also want to verify that the error occurring is actually the error you expect. So this is where you write your expected error output, that this is the file name. It tells you that it occurs on the second line of your layout.xml. It is a type of error, and this is the short definition of what the lint rule says. This is the ID of your particular lint rule. This is the unique identifier we had talked about, and it even points out in the file to tell you where exactly the lint issue is happening. And this is why I mentioned that indentation would be very important, because if you moved it, the output also would be a bit different. And here you can see that we are expecting 1 error and 0 warnings. And this is what would happen in the lint rule. Now, you might think that this is a very complicated block to write in the expected. Like you would have to see which file it is, line number, manually add the description. So an easier way to do this is just run your lint rule, let it fail, see the output that you're getting in terms of failure. If it looks correct to you, you can copy out that block and put it in your expect block. It is not exactly how I would normally write tests, but for such cases, that is fine. As long as you're making sure that the error you got was a valid error and that is what you are expecting, you can follow this method. So run a failing test case, see what caused the failure. If it makes sense, put it in an expect block and it will pass. Now coming to integration. If you are planning on integrating lint rules into your project or enabling Android's lint rule as a part of your CI, do not try to address everything at once. Start doing it incrementally. That you decided that these are the categories of warnings or errors you're getting. You would take up this category in that particular release cycle or sprint. Do it in the next category next way. So do it incrementally. Otherwise, it can be a very big effort for your entire team. And to be able to do it incrementally, what you can do is create a baseline. So a baseline is a snapshot of all the errors that you expect to have already. So consider you have this project and you decided that from tomorrow we'll make sure that whatever warnings Lint gives from now on, we will start addressing those. So you'll be creating your current project as a baseline, and anything after that should be reported. So to be able to do a baseline, you would need to write this lint options block in your module where you're running. You have to add this baseline, the function, and then give it a file. The file name can be anything. I'm calling it lint baseline. You don't have to worry if you don't have such a file. It will create it for you. Now, after creating the baseline, I'm running using Gradle. I'm running the lint debug. So it will run lint on the debug variant of my app. And you can see the lint debug failed. And the best part about lint is it will run these HTML as well as XML reports. So you can open up in browser and see visually where your text failed, what are the issues, and complete details there. Now you'll also notice in the fourth and fifth line, wrote XML report to file, which is the lint baseline, and also created that baseline file. So now you have this baseline created by lint itself. Now what happens if I run it again? I ran lint debug. This time it built a successful, but it also mentioned that one error was filtered by the baseline, the file name. If you take a look at what the baseline actually created, you will see that we had the client as Gradle and the variant was debug, and it will have a list of issues that were included in the um, baseline. So you have the ID, you have the message, you have the exact error line where the issue occurred. You have the location as in the file name. Then you had the line number as well as column number. Now you won't be getting this particular lint rule failure for this particular component again. But if you do some indentation changes in that XML file, it will happen again. Because you will see that the file, right below the file name, the column and the line number, those are constants. So if you change the indentation, that will be treated as a new lint violation and it will fail. One concern that I've seen from a lot of developers trying to adopt Lint is performance. So Lint has two ways of actually passing through your code base. One is a single pass. So you can think of it like missing attributes, like we had the style attribute. The single pass is usually pretty fast, and they are enabled by default in your IDEs. So whatever lint rules we looked at till now, they're all enabled in the IDEs because they're a single pass. But you can also have multi-pass, for example, if it has to look at unused resources. So the way unused resources would work is it would go through your like resource files. It'll keep a list of all the resources that are there. While going through your Java and other files, it will check if they are being used or not. So there are multiple passes that need to happen to make sure that unused resources are there or not. And that's the reason they can be very slow and they're disabled by default in IDE. So normally you will see that unused resources won't show up. They'll only show up if you run those particular tasks inside Android Studio and while maybe committing to your Git, you might want to run it. But that's again a manual trigger because doing it at runtime whenever you're writing code, it would be very inefficient. Now, since this is Kotlin Mumbai, so let's focus a few things specifically on Kotlin. I mean, I don't want it to be a complete Android talk because there's a lot of mention of Android. So, what are the considerations that you have to take if you are adding Lint to a Kotlin code base? First thing is, if your lint rule expects to check for the return keyword in different functions, you have to also take care of the fact that unlike Java, a return keyword is not necessary in all of your functions in Kotlin. You can just have a return block itself. So you can write a function name equal to and do some calculation and then send it back over without even writing a return keyword. Similarly, you can have cases where there's no explicit type declaration. So if you type val a equal to 5, there is no explicit declaration that this is a type integer. So you would have to extract out the inferred type and then make sure your tests are, I mean, your linting rule is accommodated to that. And to make sure such things are taken care of, usually if you're writing a lint rule, try to write it at least one test case that would be on how you would normally use Kotlin for that particular component. So it's just like a extra safety net to make sure that your lint checks are running properly. And a few references if you want to learn more about it. I have a small sample project where I have included the source code of the two use cases that I discussed, as well as some code to describe the other issues that I discussed here. You have the Google group for Lint Dev. It is actually pretty active, and the people active there are people from the Android Studio team who also work on linting. So you even have the team leads and a lot of other people there. And there's another third one is actually a talk by the team lead for Android Studio, and he has excellent talk on linting specifically for Kotlin, which goes into also pretty good depths of parsing something like a syntax tree, the things you should take care of. So it's a pretty detailed talk. And that's it from my side. If you have any questions, you can ask me related to Lint, or if you want to ask later, that's my Twitter handle. So you can get in touch anytime.
Yeah, thank you, Subhrajyoti, for your for presenting and giving a talk about the building a better code base with Android Link. Yeah, we have one question from Harun. I will be presenting that.
Okay.
Yeah,
Without sharing my screen.
yeah. So I'm presenting the question on the screen.
Okay.
Uh, yeah.
For XML lints, is it possible to add formatting options to the lint warning similar to what Kotlin format does? I actually haven't tried doing that specifically for XMLs. I have done that for Java files actually. And I think it should be possible to add a fix to change the formatting there. There would be uh, uh, a certain fixes that will do a diff and check for that. So it is possible to do that. There are methods for it, but I haven't tried it out myself, adding the formatting options for XML lints. But it is possible.
Okay. Yeah, we have a next question. Let me just switch this. Okay.
Okay. So can we write suggested fixes and please suggest some custom ones? Good. So yes, you can write suggested fixes. They can be depending upon your use case. They can be pretty simple to pretty complicated. So for example, in our case, when we had this lint rule saying that don't use like the material snack bar, we just had a suggested fix replace the material snack bar with Tickertape snack bar. So if the APIs are pretty similar, it's very easy to write those suggested fixes. I'm not sure how many people have used Timber by Jake Wardren, but if you have, you would notice that Timber's API is very similar to the logging API that we have in Android. So in that case, it becomes pretty simple to just swap out the classes invoking the function, and it becomes pretty easy to write such fixes. But if you have a very complicated lint rule that goes through maybe multiple passes or has to reference multiple files, then it becomes tricky. But yes, it does give you ways of writing suggested fixes. And even in test cases, you can even test out if the fixes work properly. So you have methods to check, like incrementally apply the suggested fixes on the lint on the files where the issue occurred. You can even check the expected diff to make sure that the correct methods and the files got changed. And about suggesting custom lints, at the moment we are just like doing it for I would say our indentation issues and following a style guide. Otherwise, we haven't really come across use cases where we would specifically want to use Lint. I mean, we started using it maybe 3, 4 months ago. But if you want to see a lot of such use cases, I can share one with you. I have one. So there are actually a lot of such. Yeah, I found the link. So this is a huge repository with a lot of lint rules written. It could be for things like RX Java. It could be, I think, for a lot of accessibility issues. Could be for resources, how you name things. Another thing you can write custom lint for is you can prevent people from hard coding colors and like we have for strings, you can make it that people cannot hard code colors in your layouts. So if ever you find a hard coded layout, you can tell them do not use a hard coded layout. Please use one of the resource files that we have. Or you can ask people to not use a certain set of colors. For example, you might have something called black, and then you might have brand primary. So if anyone by mistake thinks that color looks like black and they use the color black, but brand primary is a variation of it, you can tell them that don't use this color. Instead of this, use brand primary.
Okay. Okay. So anybody has any other question can ask or post in the chat.
I had a question, Subhrajyoti, myself.
Yeah.
So if you look at how Gradle builds the tasks, right? You have assemble, you have build as Gradle task, or you can make a custom task of your own, right? So if you
Yeah.
do something like a build, then it will traditionally pass through all the lint checks, right? But if you do something like an assemble on an artifact, it would bypass your lint checking, and it would just make a build, right? A compiled build. So
Yes.
is that understanding
Yeah.
correct?
Yeah. So, but if you're doing an assemble, it would run to check for things like fatal issues. So if you have a lint marked with fatal, it would run that.
Okay, okay.
So
So
for like assembly is a critical step, it would check for the fatal issues.
right, right. So what is your suggestion for large projects, right? Because traditionally Lint and how Lint works with larger code bases, it takes a lot of time of its own, right? Especially when you are making a local build. So what is your comment on that? Where large projects are concerned, where your code base is fairly large, right? It will take around an hour or so just to go through your
True.
lint check?
So what you can do is not enable, like, so if you have a large project already, like I mentioned, you would want to, like, incrementally start addressing things. So one way would be to use a baseline and then start looking for newer issues, or otherwise you can limit the number of issues you want to look for. I agree that it wouldn't be feasible to run everything on a very big project. So in that case, what you can do is you can have a baseline where you specify that, ignore all of these, suppress all of these lints. I don't want, like, you can think of the simpler lints, like you might want to ignore hard-coded strings, or you might want to ignore accessibility issues. So you can suppress all of them and keep only a subset of lints activated, that these are the ones you need to run on every build. So that way you can just be sure about what are the necessary things you need, and your build time also doesn't go that way.
Right. I think this question also came up in one of the fireside chats when somebody asked the Android team themselves, right, what they are doing with the Android Studio to maybe make it faster and not consume so much memory while they are building that source code, right? So
Yeah.
from the
So actually, the last I checked, the Android team was working on making, I would say, the linting API a bit more efficient. So when I was talking about the real-time linting that runs, they wanted to be able to run it in different batches, so that right now lint can get triggered for every keystroke that you do. They were working on better APIs so that it doesn't keep getting for every keystroke. Rather, they would have some kind of a timer on a batch process where after a certain amount of code has been written, lint would run, the studio lint would run, and then check for issues, just to reduce, like, the lag that you might have.
right, right. So just to share with our audience also, Subhrajyoti, the project that you are working on with the kind of lint setup you have built, with these checks, what kind of time you're looking at when you are making, let's say, a production build, a staging build? Uh, what kind of time or process you guys are looking at?
So as of now, we have linting rules mainly for our style. So for all our custom classes, we have those written, and it varies. I would say maybe 2 to 3 minutes on our CI pipeline.
Okay,
Because
that's
again, like yeah, we have suppressed a lot of issues that we don't really want to care about, and we have addressed most of our things in terms of lint. Like we have been there as exercise from this, so it's pretty fast for us.
nice. Sounds good. 2-3 minutes is a fairly good time with
Yeah.
your builds. Yes. So we have another question from Ravi. If you can open up the chat, Subhrajyoti, and just address it.
Can I look for suggested? You technically could do it. Like you could write a custom lint for this, for suggested fixes runtime. But the problem is, such a thing you shouldn't be doing for runtime, because here multiple passes would be needed. That you would have to first make sure that, so lint has this inherent order of in which it wants to, in which it will, like, pass through different files. So it could be progut files, manifest files. So there's a certain order. Now, in your case, if you think of it, before lint comes to something like your actual layout file, it would have to pass through your strings.xml, make a map of all of the items that you have in your string. Then, when it comes to the layout again, it has to come and check if the hard-coded string value matches anything in the values there. Like, it would be a pretty expensive operation because multiple passes would be needed, and hence it would actually be better if you not do that at runtime, but rather as like a manual trigger. For example, like once you're done with your code, you manually run the gradle task or your CI, but it wouldn't be advisable to run such a thing in runtime. It might just slow down your ID, or you'll get some lag while typing. So that can happen. But it's definitely possible to write such a lint rule.
Anybody has any more questions? Feel free to unmute yourselves or just drop a question in the chat. Okay, I think our viewers have addressed most of their concerns, and this was a very informative talk, Subhrajyoti. This was a fresh perspective on how we could build a better code base. And thank you for joining with us. Thank you for being a part of the community and giving this
Thank you
talk.
so much for having me today.
Yeah, definitely. It's a pleasure to have you. Uh, everybody, if you have any feedback to share, we'll be sharing a feedback form. So if you want any feedback that about this talk that you would want to share with Subhrajyoti or about the community, we'll be sharing a feedback form on Twitter. And about the recording as well, we have recorded this entire session, so it will be available on YouTube. And anybody can revisit this and some other things that are spoken here. Subhrajyoti will be sharing the links that he has shared in this presentation and here in the chat. We'll share that separately on our Twitter channel as well, and you can visit that. So thanks everybody for joining. It's really great to have all of you on this Saturday, and we'll see you guys in the next one.